Viitorul e al tău, noi punem temelia. UTCB, construim pentru România. UTCB, Universitatea de Construcții București.
I will be honored to start this seminar by this lecture, which is dedicated to the evolution and perspectives in the geotechnical design according to the second generation of the Eurocode 7. As I mentioned in the opening, we will address also this very actual problem of the revision of Eurocodes 7 and 8. So I will try to follow this summary in the next 45 minutes to present you a general overview of the revision of Eurocode 7 with the objectives, key changes, and to give you, I think, some useful information about the guidance documents that were developed and further actions. So I will start by reminding you all what were the objectives of the revision of Eurocodes in general and in particular for Eurocode 7 is to obtain at the end of this process a standard that is suitable for all design cases, to improve the ease of use, which is not always clear that we managed to do this in the second generation, but we tried to improve the ease of use. To avoid alternative rules as much as possible and not having any more textbooks or other not very useful details. Also to achieve as much as possible a harmonization. And for those of you who are dealing with the present first generation of Eurocode 7, you know already that we have many design approaches and many alternatives following the different practices across Europe. And also to have some new developments, and I will present you some details in a few slides. First of all, we are facing a reorganization of the Eurocodes, and I will refer only to Eurocode 0 and Eurocode 7, and Eurocode 8 will be addressed later on by the other speakers. So if in the first generation we needed first of all, Eurocode 0, which was basis of structural design, and the two parts of Eurocode 7, general rules and ground investigation and testing. Now we will need 4 documents at least, but these are just the basics. We will need some more. So we will have the new Eurocode 0, which is now basis of structural and geotechnical design. And this is a huge achievement for our geotechnical design community and practice. And Eurocode 7 is having 3 parts. Part 1, general rules, Part 2, ground properties, and Part 3, dedicated to geotechnical structures. What is the status now? We have already adopted in 2024 the first 2 parts, general rules and ground properties, and in November 2024 it was the formal vote ended for the Part 3 of Eurocode 7. And we are expecting, and it was approved, and we are expecting its publication probably this year in 2025. While Eurocode 0 was already published in 2023. In terms of new developments that we can find in the second generation of Eurocode 7, we can find new concept. And one of the first is the rock engineering that has been introduced all over the Eurocode 7. And now what we are calling ground can be composed either of soil or of rock. So we are addressing both in almost equal manner. The geotechnical category was redefined and now is a combination of the complexity of the structure and the geotechnical complexity, that means the ground complexity. Also, we have new definition for the representative values of the geotechnical parameters, either as a cautious estimate, as it was until now, and or by statistical approach. I will give you some details in some moments. As far as part 2 is concerned, there is a new focus considering that the user of this design code is a designer. So he or she should be mainly interested in the input for the design, which is the output for the testing, from the testing, and not how to derive a ground property and which test should be used in which conditions. So it's a little bit a different philosophy of the part 2. There are also 2 new things, but new because they are appearing now in the code, but they are not new in our practice. And these are the ground model, which is the final result and the final output of the geotechnical investigation stage of our activity, and the geotechnical design model, which is the basis of the future geotechnical design in the second stage of our activity. Also, there are new geotechnical structures that are addressed in part 3, pile groups, pile drafts, and we didn't have this until now, reinforced fields, that means using geosynthetics, rock bolts, soil nails, ground improvement techniques, and also measures for groundwater control. All these are completely new in the second generation. So now we have our little toolkit with which we will start our geotechnical design, comprising Eurocode 0, Eurocode 7, and when needed, and in Romania and in Greece we need it, Eurocode 8 because we have to perform a seismical design. Where to find the proper info? And I think this is important to understand where to look for the information. So in Eurocode 0, you will find the general design principles that are applicable to all kinds of structures, including the geotechnical structures. You will find the consequence classes and also the consequence factors, KF, that can be applied in addition to the partial coefficient for actions. You will find those values for the partial coefficients for actions and effects of actions, and the verification cases for ultimate limit states. In Eurocode 7 Part 1 General Rules, you will find the geotechnical categories, the representative values of the geotechnical parameters, the geotechnical design model. As I said before, this is the starting point of the geotechnical design, the partial factors to be applied to the ground properties, the consequence factors Km applied to ground properties or Kr applied to ground resistances, and also which are the ultimate limit state and serviceability limit states for geotechnical design. In part 2, ground properties, you will find the ground model, and it is of the highest importance for those who are doing the geotechnical investigation, and also laboratory and ground investigation. And in part 3, for each geotechnical structure, you will find the conditions for ground investigation. There are minimum recommended ground investigation quantity and quality, some aspects regarding groundwater, the geotechnical analysis that is specific for that geotechnical structure, ULS and SLS verification, partial coefficients applied to resistances, gamma R, model factors, gamma RM, that are used to calibrate, if you want, the values that we are obtaining using a certain method or theory with the more realistic values that are determined using another method. Implementation of design in execution, testing, and reporting. So this is the general content of the 3 parts of Eurocode 7 and Eurocode 0. What is important, let's say the most important things. There are also several other aspects that I'm not mentioning here. So for Eurocode 0, as I mentioned before, you will find the partial coefficients for actions and effects of actions, and for verification cases. These are more or less the same as before, but now there is a different hat, let's say, or different label, and we are calling them now VC, verification cases. And you can see here the actions, permanent, variable, and effects of actions, and also all the actions and the water actions. So now it's a different treatment for actions coming from water, either groundwater or surface water, and the partial factor is lower than for the other actions. And you can see what are the verification cases for structural, static equilibrium and uplift, and geotechnical design. This is a table that was a little bit modified just to emphasize what are the applications for each verification case for geotechnical design. And on the left-hand side of this slide, you can see the consequence classes and the consequence factor Kf that appears also next to the value in the table. And it is 1 for CC2 and plus or minus 10% for the other consequence classes. So here is an explanation, and I think Yorgos later on will also give you some details about the verification cases. VC1 is used both for structural and geotechnical design. VC2 is used for the combined verification of strength and static equilibrium, and there are two combinations, and the one which is the most unfavorable will be considered at the end. VC3 is basically used for slope analysis and embankments, spread foundation, and gravity retaining structures in some countries, while VC4 is typically used for the design of transversally loaded piles, embedded retaining walls, and also in some countries for gravity retaining walls. And just for showing you again, VC4 is the one in which we are applying the partial coefficients to the effects of actions and not directly to the actions themselves. So, going further now to Eurocode 7 Part 1, as I mentioned before, there is a new definition of the geotechnical category, and now it is the combination between the consequence class CC taken from Eurocode 0 and the geotechnical complexity class. And this is quite similar to what we are doing here in Romania, because we have different type of conditions, of ground conditions that we are considering in order to determine the geotechnical category. Why it is important to determine the geotechnical category is because this is influencing all those things that are presented here. That means the minimum ground investigation and also the minimum validation of the calculation models, the minimum design check level, execution class, inspection level, design quality level, monitoring, and so on. In yellow, you will find these aspects treated in Eurocode 0, while in green are depicted those that you can find in Eurocode 7. The representative value now in the first generation of the Eurocode 7, we are talking about characteristic value of a geotechnical parameter, and the definition of this characteristic value is not very clear now, and it was then revised, and now we have two possibilities: either to determine what we are calling characteristic value by statistical approach, by statistical means, or to have a nominal value of the ground parameter based on engineering judgment, the former cautious estimate that was mentioned in the former code. Those two represent together the representative value of the ground parameter. On the right side, you can see a scheme, this one, a scheme showing that the representative value can be either nominal or characteristic, and this is determined on the basis of the derived values that we can find in the geotechnical investigation report. Also, we can use data from monitoring and to perform back analysis, and in this case, we are determining what we are calling a best estimate value of the ground parameter, which is used for prognosis. We are extending now this idea of the representative value also to groundwater pressure, and this is also a major change. And now, if we have long time records of the groundwater level, we can define the representative value of the groundwater pressure either based on one single permanent value of the hydrostatic level, either the upper or the lower value, which one is the most unfavorable, or a combination between a part which is permanent and it's more or less the mean value or the average value, and the variable component that is will be affected by the partial coefficient for variable actions. The problem is, I don't know for Greece, but for sure in Romania we don't have databases for the groundwater levels. And I suspect that in many other countries this is the case. So in our case, we will not be able to use the database, and we will have to base our analysis on the cautious estimate of the groundwater level and then therefore the groundwater pressure, and this will be called again nominal value. So whenever we are using our judgment and we are not performing a proper statistical analysis, the resulted value will be called nominal value. I mentioned already the ground model and the geotechnical design model, and I explained that the ground model is the final result or the output of the geotechnical investigation report, while the geotechnical design will be developed at the beginning of the geotechnical project. And just for showing that ground model issued from the geotechnical investigation report can be cross-section with the lithology, but also for each unit that has been identified, we will attach the derived value of the geotechnical parameters. And after having this ground model, we will add the geotechnical structure that we want to design. We will put further the relevant limit states and the relevant design situations, and we will have to determine as geotechnical designer the representative values that are adequate for the limit states that we are analyzing. And with this, now that we have the representative values of the ground parameters, we will determine the design values by applying the partial coefficient for ground parameters. And all those information will compose the final geotechnical design model. And I would like to mention that this geotechnical design model is not unique. So depending on the limit state and on the design situation, we can develop more than one with different levels of details, with different values that are considered to be representative for that situation. And there is something more that both the ground model and the geotechnical design model have to be validated. And here I am giving an example taken from part 1 of Eurocode 7, second generation. What are the measures to validate the geotechnical design model? What is the idea? Why validating? Because we need to demonstrate that using that specific geotechnical design model, the required reliability level is reached. And therefore, we can have an information about the all remaining uncertainties that we will have to address in another way. Okay, there is always a certain level of uncertainty that we are keeping with us, but we have other methods to mitigate this risk. Now for the verification of the limit states, we still have the 4 possibilities that we already have now. That means verification by prescriptive rules, verification by calculation, by observational method, and by testing. And I will address here in some words only the calculation and the observational method because the 2 others are quite clear and we are applying them all the time. For the verification by calculation, which is probably in more than 90% of the cases the method that we are using in our geotechnical design, now it's a little bit simplified. That means that we have one unique equation to verify, which is this one that you can see on the screen, ED less than RD. That means the design value of the effect of actions should be less than the design value of the resistance. And here, those of you who are applying the first generation of Eurocode 7 know that we have the three design approaches, DA1, DA2, and DA3. In Romania, we are applying DA1 and DA3, while in other countries, they are applying different other combinations. We are now speaking about MFA, material factoring approach. That means in this case, we will apply the partial coefficients to the ground properties, to the geotechnical parameters, or the RFA, the resistance factoring approach. That means that in this second case, we will apply the partial coefficients to the resistance. So now we still have those possibilities, those two possibilities. We still can choose between those two. And in some cases only, we decided and we harmonize it across Europe. But in most of the cases, we will still have differences of the practice. In terms of observational method, I think what was in the present code in the first generation was not very clear for everyone. So now it was extensively improved, and it is more clear, in my opinion, that this is a quite complicated, continuously managed and integrated process of design, construction, monitoring, and review. So it's not just let's see how it is going and we will fix it on the road. No, it's not this. We should have more than this. And I think that the text in the code now is more clear about this. For the partial factors on ground properties, when we are applying what I called MFA, material factoring approach, you will find these values in part 1 of Eurocode 7. You can see here on the screen the two sets of values. The most important ones are the same as before, but there are some additions, notably also for rock materials and rock mass, rock discontinuities, and also for interfaces. And after each value, there is a Km, the consequence factor that is applied to ground properties, and you can see the values on the left side of the screen for this consequence factor Km. There is also a new addition regarding numerical methods. Of course, if we are thinking that the first generation started to develop in the 80s, we didn't have the numerical methods in the previous code. But now we have something, and you can see here that there are two ways to apply or to use numerical methods, either by factoring the input values and also some of the output values, and this is used for analyzing geotechnical ultimate limit states. Or another way to do it is to only factor the output values, and this is mainly used in structural ULS. I will not insist much more about this, but now there are quite clear rules how to do it. For part 3, I am not addressing much in this talk today, part 2. So I will go directly to part 3, geotechnical structures, and you can see what are the geotechnical structures that are addressed in this chapter, with the 5 last ones that are completely new. That means reinforced field, soil nails, rock bolts and rock surface support, ground improvement, and groundwater control measures. I will speak a little bit about some of them, but not about all of them. This I already presented and I will skip it. For slopes, what is the new addition is that you can find in appendix a table with the calculation models for analyzing the stability for soil and fields, that means similar as soils. And also another table for the stability of rock masses. And you will find here all the common used methods for stability analysis. For the analysis of the ULS for slopes, here we have a harmonization. We are only using MFA, material factoring approach, and only verification case 3. For this, it was simple. I would like to draw your attention about the fact that all these tables with values that I am presenting you are NDPs. That means national determined parameter. That means each country can change it if they have a good reason for doing it. We don't have to explain anyone why and how we are doing it, but these are the default values and we can change it. For spread foundations, now we have a wide application of this chapter, pad, stripped, raft foundation, but also unreinforced working platforms, load transfer platforms over rigid inclusions, deep foundations as caisson, and partly also for gravity retaining structures, gravity retaining walls. What are the new things? A little bit, not many new things, but we have the general bearing capacity formula in the main text with the values for the bearing capacity coefficients. There is a new depth factor, which is called D, and in appendix you can find specific calculation models for some cases, as for example, strong over weak layer, Menard pressure meter test, or for rock ground. Both MFA and RFA are allowed for ULS analysis of spread foundations, and you can see here in this table, which is again an NDP, what are the verification cases and the material factoring approach and the resistance factoring approach for each case. Of course, I don't have the time to insist upon this because we are not doing a training, but just a general overview. Also, you will find, and I know that there are many structural engineers here in the room, you will find a very useful guidance for SLS analysis on bearing pressures for structural analysis, for rigid and flexible foundations, how to determine the relative stiffness of a spread foundation and how to determine the subgrade modulus, and also how to use the linear elastic spring stiffness. And there are also recommended value, again an NDP, for the limits for the load eccentricity. And these are, I think, useful data for both geotechnical and structural engineers. Piled foundations, and here we have to talk a little bit more because this clause was extensively revised, really extensively revised. And we are starting with the classification of piles in displacement, replacement, and some other type of piles. And this will influence the partial factors to be applied to ULS. So this will depend on the classification that we are doing from the very beginning. This clause will apply either to single piles as until now, but also for pile groups and piled rafts. In the part devoted to actions, we will find some new things regarding cyclic and dynamic actions, and also actions coming from the ground displacements, as for example, down drag, heave, and transverse loading. And there are some calculation models, either simplified or more accurate or more sophisticated. We can use either prescriptive rules, calculation, or testing, while observational method is not so widely used in case of piles, either for compression, traction, or transversal loading. In terms of actual resistance of a single pile, two methods are defined, and I agree with some of my colleagues that maybe the names are not very suggestive for what it's inside. One is the ground model method that is based on the ground parameters determined either by laboratory test or by in situ test. And the second method is the model pile method, that means based on individual resistance profiles determined or either from CPT or pressure meter mainly. You will find a very useful table with model factor. As I explained before, this model factor is intended to cope with the bias between the realistic value, because I cannot call them real value. We don't know exactly, maybe in every case, what is the real value, but what we are considered a more realistic value. So we are trying to calibrate the result of the application of one of these methods. And you can see for ground model method in different cases, values starting from 115 to 155. And for model pile method, there are less, smaller values, because of course, when we are basing our design on CPD or pressure meter, the values are more realistic. We have also some consideration about the design by testing. For static pile load, the static pile load tests are allowed for ULS and SLS in compression and tension, while the dynamic load test and the rapid load test only for ULS for piles in compression. Again, model factor for single pile for design by testing, depending on the different type of testing. And again, if it is a static load test, the coefficient will be 1, while if we are using less reliable method, the value will increase. As I mentioned before, now there is a subclause devoted to pile groups, and here we can apply either numerical, analytical, empirical, or observed performance for the analysis. And of course, we have to consider different type of interactions as pile soil and pile. For pile drafts, there are some considerations also, and here we have to consider more types of interaction: pile soil, pile, raft soil, and pile raft interaction. For pile foundations, you will find the partial coefficient for resistances, and here for the axial resistance, there is only one option, RFA, resistance factoring approach. And for the transverse resistance, you can choose between MFA and RFA. And this is the table if you are using the ground model method. And you can see that it's a little bit complicated. It's not a very simple table, which is again an NDP. And there is another one for the model pile method applied to piled foundations. And another one for the design by testing, again for piled foundations. For pile groups and pile drafts, there is a different table for the verification of the ultimate resistance. For the vertical resistance, we have again the choice between MFA and RFA, while for the combined axial and transverse resistance, only MFA can be applied. For SLS, here again there are some very useful additions. The displacement of piled foundations for single piles, there are such aspects as settlement and transverse displacement, load curves, also for pile groups and pile drafts by using different kind of methods. There are calculation models for single lateral and axial displacement using load transfer functions, and also a calculation model for buckling of piles for very slender piles and second order effects. And a very new addition, which is answering to the requirement of the European Commission to address sustainability aspects, there is an Annex K about thermoactive geostructure design, so for geothermal piles. For retaining structures, there are not many new things. Formulae for the determination of earth pressures, calculation models, rules for the application of the different type of models, limit equilibrium, beam on spring, or numerical continuum models, and also again the same annex about the thermoactive geostructure design. Both MFA and RFA are allowed for analyzing ULS for retaining structures. In terms of reinforced field structures, here I will not insist more because it's a completely new chapter and there are many, many things to consider. We will find all the applicable ULS here, the tensile strength, how to determine the tensile strength of the reinforcing element of the geosynthetic, the pull-out resistance, the sliding resistance, and so on. And again, both options are available, MFA and RFA, so each country will choose between those two. The same is applicable for soil nailed structures, again with the two choices. For ground improvement now, this is also a completely new chapter. We are starting also with a new classification, which is not always very easily understood. We have 4 classes. Class A is diffused, a diffused improvement, and Class B is a discrete improvement. And also Class 1 is with no measurable unconfined compressive strength, and Class 2 is with measurable unconfined compression strength. That means that for A1 and A2, we can use the equivalent parameters of the improved ground, while for B1 and B2, we need to consider the possible interactions between the inclusions and the surrounding ground and so on. And here we have, for those 4 classes, different methods how to address how to verify the ULS, and this is quite clear, in my opinion, for the 4 classes. And we have partial coefficients for resistances, and we have, in general, both MFA and RFA, but for B2 class, for improved ground, there will be an additional partial factor gamma M applied, while for B2 rigid inclusions, we will apply also the general design principles for piles and pile groups. This was the very general overview of what was happened in Eurocode 7, the 3 parts. I would like to give you some useful information about the guidance documents, how to apply all those new things. And you can see here on the screen a link to the JRC website, where SE7, which is the subcommittee dealing with Eurocode 7, developed and published 4 guidance. The last one was just published 2 weeks ago. Jose Estaire from Spain was the convener of this group and the editor-in-chief of this guidance. Determination of representative values from derived values for verification with limit states. And there were 3 others published in 2024, how to assembling the ground model and how to determine the derived values, very, very useful for those who are performing geotechnical investigation. Implementation of design during execution and service life. George Tsitsas, you contributed also to this guidance. We also have Alexandra Ene and also our colleague Adrian Priceputu, who were involved in the development of the other guidance documents. And the last one, the one in which Alexandra contributed the most, reliability-based verification of limit states for geotechnical structures. All 4 documents are very, very interesting, and you can download them for free on the website. There will be 2 others that are now under processing at JRC. One is the report of task group B1, which did a testing of the code by next generation engineers using day-to-day case studies. And those very young engineers working in the industry, they took their projects, their normal projects, and they tried to solve them using the whole series of documents, not only one document. And they proposed for publication this report, and we hope that this year will be published. And the second report, and I had the honor to lead this task group B2. This one is devoted to design examples. And maybe some of you already remember that for the first generation of Eurocode 7, there were some design examples, very simple ones, that were done by the former group led by Trevor Orr from Ireland, but they were not able to publish them because it's a lot of work behind to edit this kind of report. So we took over their examples done with the first generation of Eurocode 7, and we solved them again with the second generation with the new code. Also, we added new design examples for the new geotechnical structures. So in total, there are 25 design examples for the main geotechnical structures. And together with Yorgos Velokas, this is another example of very good cooperation between Romania and Greece. We are co-editors of this report, and Yorgos developed some very nice and very useful flow charts that I think will be very, very useful for you to try to get used to the new concepts and the new flow, let's say, of the design. I think Yorgos will present a little bit of those flowcharts, and again, we are hoping that this year, 2025, we will see also this second report published by JRC. Further actions. So, as I mentioned before, we have already Eurocode 7 Part 1 and Part 2 already published. For the Romanian people in the room, it is already adopted as Romanian standard, and there should be a work done this year for the translation of these two parts and also for the elaboration of the national annexes. The third part we are expecting this year to be published, and there are two other parts of Eurocode 0 for new structures and existing structures that should be voted at the end of this year. And also we should work on the national annexes, because we have to respect the deadline, which is September 2025 for the national annexes. I would like also to mention the fact that TGB2 organized a benchmarking exercise, and we presented the results during the seminar in Paris last October. Not many countries unfortunately participated, but what we saw is that there is still a lack of understanding and the need of future actions, both at national level and at European level. I am discussing now with SE7, with the European Regional Technical Committee 10 of HSSMGE, in order to organize several actions together for widely disseminating all those aspects. But I think that at national level is very, very important for every country to organize different kind of actions in order to get used the people with all those things, which are not always very, very easy to apply. So we have in SE7 an NSB contract group. NSB means National Standardization Body, which in Romania is ASRO. And we are discussing different aspects, how every country is dealing with a certain aspect and so on. Is very useful for us for preparing the work for the elaboration of the national annex. Maybe you know that in 2026 we will have the 21st International Conference of Soil Mechanics and Geotechnical Engineering in Vienna. And for this, we proposed from SE7 12 papers dealing with different aspects of the new Eurocode 7. And we are discussing also the possibility of having a workshop. And again, for your agenda, because it was not officially disseminated yet, please note that between the 3rd and the 5th of June this year, there will be a JRC online workshop for all the new Eurocodes, not only Eurocode 7, but for all the Eurocodes. It will be online. And on the 4th of June, In the morning, this is why there is a red arrow, because they change it and I don't have the final version. We will have 1 hour and 15 minutes to present some aspects regarding Eurocode 7, but all the Eurocodes will be presented starting from 0 until 9, Eurocode 9, and also some other documents, design of fiber, polymer, composite structures, and so on. So please put in your agenda this seminar. And with this, I hope that it was useful to make this overview and this final part with guidance document, and I am thanking you for your attention.
UTCB, viitorul e al tău, noi punem temelia. UTCB